reactivity and the periodic table. So you can use the periodic table to predict the reactivity of different groups, at least. As you move down the left-hand side in groups 1 and 2, reactivity increases. And as you move up the right-hand side, in groups 5, 6, and 7, reactivity increases. Nothing much happens in group 8, also known as group 0, because those are all noble gases, so they don't react with anything anyway. Now this all happens because electrons have a negative charge. And these electrons are attracted to protons, which have a positive charge. The protons are found in the nucleus, and the electrons orbit around the outside. And remember, it's those opposing charges that bind them together. The greater the distance between the protons and the electrons, the more weakly they're bound together. So you think about each individual electron and its position, and you can judge from that how tightly it's bound in. So if we look at it in practical terms, if I use my nice red pen, here we go, we'll put an electron on there. It's nice and close to the nucleus. It's really tightly bound together. If we wanted to get another electron to bind in here, we'll have a little blue cross. That would be quite easy. It'd be quite easy to get another electron to bind in there because it's very close to the nucleus, which contains all of the protons. Remember the protons there in the green P in the middle. They're nice and close to the electrons. If we move further out onto the second shell, that's not the second shell, you fool. That's the second shell. If we move out to the second shell, all these electrons are still pretty close to the nucleus. So it's quite hard to pull them away, and it's fairly easy to draw electrons in because there's lots of space in that area. The further out you get, though, the greater the physical distance is between the nucleus and the shell. So if you think from here to here is a much greater distance, and we go out to the next one, that's an even greater distance. And the further out you go on these shells, the easier it is to pull electrons away and the harder it is to attract electrons in. So how does that apply to the periodic table? Well, think about it this way. Now, as you move down the different periods, remember periods pass from side to side. As you move down the different periods, you get further away from the nucleus. So the distance away from the nucleus increases as you move down. All of these group 1 and group 2 elements want to lose electrons. So it's easy for these guys to let go, or easier for these guys to let go of electrons. Apart from hydrogen, which is a bit of a funny one, but we'll pretend hydrogen doesn't exist just for the time being. It only makes up most of the universe. And up on the right-hand side, for elements in groups 5, 6, and 7, particularly 6 and 7, as you move up the table, it's much easier to attract electrons in because there's a smaller gap between the nucleus and the first shell that's got some space in it. So down at the bottom here, there's a much weaker attractive force than there is up at the top around here.